off, kudos to you guys. You are awesome. By the looks of it, we're able to just do 10, 1, 3 today, 4 tomorrow, 5 on Wednesday, and then have a few days to review whatever we want before taking the state test. So that's our plan. We don't need to rush or combine or anything like that. I'm guessing we'll get done with today's lesson in like a half an hour, if even that long, and have time to work on your practice. So while I've been announcing and encouraging, like, keep your foot on the gas, like, get through that yellow light, whatever, like, you're going to start to feel us ease up a little bit, because we're reaching the end, really, for what we need to get through and study and learn, and yeah. So we will get back to your assessments at some point. I know most of you weren't done, and I did not even go in and give feedback because I was trying to figure out this week. But I don't want to rush any learning or anything, and I care more about learning than I do about assessments. I don't know. It would make, in my brain, it makes more sense to fit in another day learning now and deal with assessments later in the month after the state test than to keep testing you now before the big test. I don't know. If it was my option, I wouldn't test you guys ever. I would just give you opportunities to show that you know what you're doing. Yeah.
On math it says I have chapter 8 homework missing, but I turned that in already.
I probably have not updated it, depending on when you turned it in. I had updated everything prior to Thursday last week. So, if so, we might need to chat. So that's more of an AO extensions question, right? That's you directly. The other 20-some people in here can't help us with that. General class questions before we dive in, or anything from last week that we were still having any issues with. Yes.
So, I'm still confused about how we find the square root of a large number if we don't always have them.
Like a non-perfect square large number?
I guess.
You mean simplified radical form, or just the approximate, like?
Radical form.
So to be able to be put in simplified radical, the value trying to be square rooted. Sorry, this gets awkward how to talk about all this. So like square root of 16 is doable because we know 4 times 4 gets us 16, or negative 4 times negative 4. So if you were given something like square root of 32, this is where a simplified radical comes into play. 32 itself is not a perfect square. However, in it is a perfect square. And there's some really specific rules to like square roots and stuff. We cannot do this with addition. But because the square root operation deals with multiplying and dividing, we're allowed to use our multiplication division rules. And we know we can break apart, like we can factor a number, right? And it's still the same thing, right? Like 16 times, that's still 32. So this is still that, right? We're applying these rules. We know this would hold true. And we could test this, actually. So we then further can extend this rule and say that is the same as each of them being square rooted and then multiplied, right? Square root, then multiply them. Well, I can square root this. I can't really square root that. So this is actually the simplified radical form of square root 32. All you're trying to do is find the perfect square root that is a factor of the non-square root. Now, if you're given a value like square root 50, in your head you might be thinking, oh, 49, that's a perfect square. But that's not a factor of 50. So for 50, we have to think, is there a factor of it that's a perfect square? 25. Now, we have to work in integers still. So we wouldn't use like 16 and some gross number. Like, we wouldn't do that. So this only works if it breaks out nicely, right? Because this is trying to make things nice. This becomes 5, and then the radical 2, we still don't want to do it, so we leave it radical 2. Does that help at all, Savannah? What?
No.
Okay, so give me more then. I need more. If that doesn't help at all, I don't know what you're talking about.
I don't know.
Is it not simplified radical form then? Are you talking about like on the test where it said approximate radical 110?
I think.
So I'll pull 130 because if I do the question from the test, that's just not fair. So if we look at a problem like find the square root of 130, it's still one of those, is it a perfect square? Probably not, because most numbers aren't perfect squares. So if we think about our perfect squares near here, 10 times 10 is 100, 11 times 11 is 121. That's pretty close. So I'm going to go ahead and write that down. And that is 11 squared. 12 times 12? 144. Ooh, so I found my in-between. So we know that this is in between 11 and 12. So in the end, my answer is going to be 11 and something. Right? 11 point something or 11 and some fraction. Now, to review the Rachel method, which, true confession, I didn't look at your tests, but I bet a lot of you forgot this. The Rachel method is not, Rachel was a previous student of mine. This is not an actual, like, math name. There's probably a name for this, but it's just approximating square roots. How far apart are these two perfect squares? Well, from 21 to 44 is 23. So and again, this is an approximation technique. So these should actually be squiggly equals. We make our denominator the whole distance between the values. Then we ask what portion of the distance has been covered. 9 of it. Those are the two ways that we can deal with there might be more, but those are two of the ways we deal with non-perfect squares. Okay, we can either, if there's a perfect square that's in it, so if I think of 130, I can't really think of a factor of it that's a perfect square. Right, I can't think of, it doesn't have 25, doesn't have 36, doesn't have 49. We're getting pretty big. So if that still doesn't help, I think we need to meet and talk some specific problems.
I'm confused on how you got the whole number 11.
Because we know 130 is bigger than 121, and if I had square root of 121, that's 11. If I had square root of 144, that's 12. It has to be between 11 and 12.
Okay.
Yeah, that's how we make that choice. It has to be 11 and something. Other questions? This is good. This is exactly what we need to start class with. What do you need?
Do you have graph paper?
Of course I do. Top drawer right here. I have graph paper for days. Lauren knows that. Just take a pack if you need.
I just wasn't going to be the one to walk in and get shot with a side.
At this point, what do you need? All right, other questions. Trying to utilize weight time to make things awkward. Okay. So we are going to continue talking about surface area and volume, but specifically with cones and pyramids. And this lesson, what we're going to start on today, is all specific to volume. But then if we have time, so they go volume, and then they get back to some surface area. Mainly in 7th grade. Well, okay. So let's be real clear about this. This probably won't be on your test. Pyramids and cones are more of an 8th grade standard than they are a 7th grade standard. And I tell you this hoping to whatever entity there might be that it's not on the 7th grade test, so I'm not going to get to it with the other 7th graders. So, pretty sure it's not on there. We're doing this as your 8th grade learning that hopefully you won't have to do next year because you need to learn the high school stuff. So, we talked about this last week, and without me making a whole mess up here again, and my carpet's probably finally dried out after the weekend, what did we realize? What did we come to figure out when we dealt with these shapes? And we were pouring water, and we had a cone that was similar to a cylinder, and we had a pyramid that was similar to a cube. What did we say about all this stuff? Quinn?
That I almost got a bunch of water dumped on my head.
Quinn almost got a bunch of water dumped on his head. By the way, does this belong to anyone? My math art class? Somebody left this. Connor?
If the pyramid is the same dimensions for the square, and
So the bases are the same.
it's basically
Right.
the same, and the height is the same. It's going to be 1/3 of it.
Ah, so we hypothesized and poured some water, and it looked pretty legitimate especially when we like flipped this and shoved it inside, that the pyramid was a third of the corresponding cube. And did that hold true for our cone?
Yes.
Wait, did it hold true with other shapes?
Well, that's a different question. That's beyond today's lesson. So think about an ice cream shop. I had this thought over the weekend because I wanted ice cream and we didn't have any. This kind of comes into play of like how much ice cream you get. So I used to kind of be under this impression of like, man, look at the cone. They'd like fill the cone and then you'd like stack ice cream up on top of it, right? And you get the cup and they would just like fill the cup and like hand it to you with like the like flat at the top, and I'd be like, yeah. And I'd always feel like I was getting ripped off with the cup, like why not? But if the cup has the same dimension as the cone, this holds 3 times as much ice cream as this. So technically, for these to be fair, I need twice as much ice cream sitting on top of the cone as what's inside of it to make it equal to the cup. That's
The cup and the cone.
well, but so this is where ice cream shops like they also had to buy the cone, right? The cone cost money, so, but not probably as much,
No.
right? Like a paper cup or a styrofoam cup, like probably pretty cheap. So guys, think about this. Like if you go to open your own ice cream shop, like that would be a thought that some people might not take into consideration. But like this would be a third of this. It's not exactly fair, or like I don't know. You have to make some determinations. Just a thought I had because I wanted ice cream.
Ice cream, you scream, and all scream, that cup comes and gets weird.
Who what? So on that same thought process, a movie theater is debating changing the packaging for their popcorn. Now, one benefit would be you couldn't set this down and just leave it somewhere, but the drawback would be, or if you set it down, it tips. You get popcorn everywhere. So, I'm debating if we should just skip through this if this makes sense. I'm trying to cover a decent amount of content in a small amount of
Cone is a
time.
better deal. Yeah, it is.
Wait, what shape
Yeah,
is it larger if you have the same
2.5
base?
times 3 is bigger than 5.5.
Yeah. Well, you have a larger amount in a different shape at the same base too.
Okay, so let's make sure we've got this thought process in our head. By the way, when you sketch these things on your paper, it sometimes helps your brain to give like a dotted of what you can't see. So they say small popcorn's in a cone. It's $1.50. Large popcorn's $3.50. Both have the same height. Okay, so I'm going to label H just to help us out. And that's height, vertical height, not slanted height. Please make sure you get that clarified in your head. When we talk about the height of a pyramid or a cone, it's the straight up from the center height. And bases with the same circular area. What did we call the base last week? Brayden?
No.
A lot of
What?
space.
It's Big B, yeah.
Oh, right.
What do you mean, oh, right?
Oh,
Guys,
yeah.
make me feel like it just goes in one ear and out the other. You can't even remember the...
I can't even remember our own name.
You guys like all lost it last week.
Yeah.
Worship.
So,
Stuff in my ear, so I forgot what it actually meant mathematically.
if they have the same base area and the same height, and guys, you'll probably believe this at this point, I do this sort of math in the grocery store. Like standing there in the aisle, I literally calculate these things. Now, some items have on the price tag like a unit price, and it tells you the price per ounce or the price per whatever. They've started to put that on the price tags, not like you have to find it on the tag, and it's normally not on the sale tag. Depending, you have to like lift it and look at it. How did we say the volumes of these compare? We talked about 1/3, but the other way to talk about it would be Yeah, times 3, right? So instead of times 1/3 times 3, what does that tell you about the deal of this? So let's imagine this was a test question, right? And it gave you all this information, and then it said, from the information given, what can you infer, or like what would you decide, which popcorn would you purchase if you were looking for the best deal? And they often phrase things like that, the best buy, the best deal. Who can talk about that? What would you write? Neither of you guys. You control class most of the time. Gabe.
I would buy the large.
Why?
Because if the cone is 1/3 of the cylinder, then 1.5 times 3 is 4.5, so therefore the large is a better deal.
Yeah, if the pricing were consistent here,
Oh, I forgot.
this should times 3. So the fact that it doesn't, and it's less than the 450, means it's a better deal, right? Now that's if you want more popcorn. Okay. If you only want a small amount of popcorn, then whatever. Questions on why that's a better deal?
Well, maybe you can't have popcorn.
So with your team, we're going to skip that next question. We're going to skip all the way down to here because I think we can probably go through this lesson pretty quickly. Read through this with your team and make your own determination. I will pull a random card to get some feedback from someone.
I already know what's better. It's a better deal. I need my finger puppet out.
So they also do this because if I wanted to do this as a lab, I could use popcorn and it's less messy than water. You know what I mean? Or you can use popcorn kernels to pour things and like, but water is more fun.
Popcorn kernels.
You know when I told you to take a pachygraph paper and you didn't?
Oh, sorry. I'll take a pad.
I mean, I don't really care. We should keep a supply out in the library somewhere. That would be a smart idea.
Yeah, that would be.
Wonder why no one's done that.
I'm probably just going to use the library.
George's cards on top. Simon Wirtz, what do you think about the deals of popcorn here?
Deal or no deal?
Why?
Because once again, it holds more and it doesn't cost as much as getting free of the.
Alright, so the manager overhears you talking about this. And he comes to me and he says, "Sir, you sound more intelligent than our staff here. We need your help. We want the deal to be the same. How," now you don't have to tell them specifics, how could they make the deal the same? What are 2 different options they have? The easy option would be change your price, right? Now the more difficult option, what if he says, "I don't want to change my price. I like $5.50. People won't pay more." What else could they do if they want to make the deal the same? I'll move on from you because Braylon's got his hand up. Yeah, but that's kind of wasteful. What's another, instead of just saying put less popcorn, what do you mean with the shape? If you put less popcorn in it, what are you changing? The height, right? If you fill it less full, say your popcorn only comes up to here, so we could either decrease the height, or if we wanted to keep the height the same, decrease the base, right? Change the base's dimensions. So if we wanted to make it the same deal, and again, this is Rogue for CPM, they don't have this question, but if you were tasked with make these the same deal, so people just buy whichever one they want, they don't sit there and try to calculate which one's the better deal, we have those 2 options. Yeah, we could solve this. We don't really have to.
We don't
What is that?
Whoa, hey.
So a lot of you guys are like immediately shying away from these, but these are presented to you in a relatively easy manner. You're just not reading it before you're going. So give me your eyes for a second. Put your pencil down. we talked about a famous dude dealing with triangles. You remember this dude who was pretty famous for triangles, and he had a secret society, and they used the pentagram.
Illuminati.
And that's not a person. You all think you're funny.
Oh, no.
Lizzie's got it. Who is it? Pythagoras. Now Pythagoras gave us this theorem relating to triangles. However, one triangle specifically won the award for like the best right triangle. Do you remember which right triangle that was?
Oh, yeah, I do.
George?
The 3, 4, 5 triangle.
The 3, 4, 5. Now I want you to take a moment. 30 seconds, no talking. Your mouth stays shut unless you need it to breathe. How could that relate to this problem? 30 seconds, no talking. Go. Shh. Halfway there. I'm remixing my coffee and my creamer for anyone thinking that I'm just crazy. I'm not like running a science experiment here. Or my creamer won't cut separate. 5 seconds. Now, can anyone give me the one word that would tell me how this situation relates to the famous right? I just want one word.
Yes.
Nope.
Even?
No other.
Divide.
No, but you got the right first word. The first letter.
I was going to say, wait.
Ooh, I'll give you that one. But more specifically, except I misspelled it because you guys all said it at the same time. It scared me. How is this a dilation? Well, Miss Tasse already answered that. It's double 3, 4, 5. This has to be 10. So here's what this problem is trying to show you. In any 3D cone or pyramid, we can drop an altitude, where altitude is the height from the ground, so that straight line, like a plane's altitude is that straight line, and make a right triangle and use the Pythagorean theorem if we choose. So sometimes that works out super duper nice. Other times we get some of those weird irrational, or not irrational, but non-perfect squares. It's okay, but we'll just end up with approximate values. Now, continuing on in this whole, like, don't freak out and shy away from things that look harder than what we dealt with. If we come down here, we haven't done much with hexagons yet. A trick that you'll learn next year is any regular polygon can be broken up into matching triangles, and that's how we could find the area of the base. However, they tell you Big B here. So for a while you're getting comfortable with this, they tell you the area of the base is 128. So that 2 looks a little funky. Then we would multiply that by the 15, right? Not 1.5. And then do what with it? Divide by 3. So hold up. Couldn't I just do that now?
What?
So for a while, CPM's going to keep your numbers nice. One of the values involved in a pyramid or a cone will likely be divisible by 3. So we could go ahead and do that now and just multiply 128 by 5 because we've already done the 1/3. So that's it. That's pyramids and cones.
That doesn't make any sense, but I got it.
What about something like ovals or other types of shapes?
We're not going there this year. So technically, in case you don't have it from last week, and I don't think I ever wrote it down today, volume of a cone or pyramid, any cone or pyramid, 1/3 the area of the base times the height. Now the base doesn't have to be a regular polygon. Excuse me, it can be an awkwardly shaped polygon. Doesn't make a difference. Just like a triangle, area for triangle is 1/2 base times height, right? Always. Doesn't have to be a perfect triangle. It can be an awkward triangle, and it's still 1/2 base times height. Because that's 2 dimensions, right? 1/2 base times height. But now we're talking in 3 dimensions, 1/3 big B times height. We say big B to make sure that we care about it being the base area.
What about the base divided by 3 and times by height?
So with multiplication and division, if I multiply these and then do the division, or whether I divide these and then do the multiplication, it's the same.
So
Remember, it tells me
128 by 3.
no, because this division by 3 does that. We only do it once. Okay, so it doesn't matter when you do it, because multiplication division
No,
happens.
like if you don't do the 15 divided by 3.
Correct. We do it once somewhere. So you're getting yourself hung up on, like, you're right. We just have to do it once somewhere. So we could multiply those, then divide. Or we could divide this, then multiply. Or we could divide this, then multiply. Yes. Other questions on this? Now, I debated moving on. Now, we're not going to, but if you are one of those worker-aheaders and you're trying to do your homework before we get there, for a sphere, if you want to put it in your notes, just to have it. Sphere, right? That's my lame attempt at drawing a sphere. Volume of a sphere. We talked about this last week because I talked about Pac-Man. It was a true question on Who Wants to Be a Millionaire. 4/3 pi times the radius cubed.
Whoa,
And now that I've brought it up, I'm going to see if I can find that Who Wants to Be a Millionaire. So tomorrow we will process through that spheres lesson and probably still have homework time. You have almost 15 minutes to work on homework right now. Yes.
I haven't seen that word. Don't question me, alright? Don't question me.
Oh, that's the word.